Hello, everyone. Welcome to one more Decks of Dev stream. Today, I have a guest to show you. Actually, I had a guest last time and the other time. Okay, never mind. Well, we do have a guest today, just like we always do. And our guest today is, what's the button I need to press here? Streaming is hard. I'm sorry. We have this guy, Thomas Rempelberg. Who the hell are you, man? I have talked a lot about K-Sync in talks in the past, so it's good to meet the person who came up with it. So you said you did some hacks to make Kubernetes work. So what you're saying is that you did make Kubernetes work? That's a bold claim. Oh, okay, okay. Yeah. All right, so let's get started with the content here. Um, Wait, he's on mute? Oh, they can't hear you. Oh shit, I'm sorry. I did a wrong thing here. Uh, can you say hello, Thomas?
Hey there.
Okay.
Is it
Um,
working now?
can everyone confirm that you can hear him now? Because I think I found the wrong button. So let's. Oh shit! I feel terrible. I can't believe. Okay, let's give it a second so people can confirm that they can hear you. And okay, now it's okay. All right, sorry everyone. Right, so I'm gonna put the logo back on the screen, and then I'm gonna put the cameras back again, and we're gonna pretend nothing happened. Hello everyone, welcome to the stream. You're seeing me and Thomas here for the first time. You didn't see anything before. So Thomas, who are you?
Why, it's fantastic to be here again. I mean, for the first time. So I'm a contributor to Linkerd, which is a service mesh for Kubernetes. But to bring it back around to why I'm here for this, a couple years ago, I created a tool called Ksync that makes it so that you can update and develop on top of Kubernetes super fast. And I kind of did that because I'm obsessed with trying to figure out how to make my own personal development experience as fast as possible. And based off of a conversation we had earlier, I also tend to have a little bit of a obsession with trying to do all of my development remotely. While I don't have a 12-year-old ThinkPad, I do prefer the iPad life where you don't have to drag a desktop around. And so it's all been towards that goal of getting faster and better on this cloud provider hardware that you don't need to host in your home anymore.
Yeah, I was just telling Thomas that I have a I think 12-year-old ThinkPad here. It's like my little pet, and I like to do development on it, but it can't run anything basically because it's very old. But if you're doing remote development, who cares? Everything's running on a remote cluster, so problem solved. Um, okay, so now let's get started actually, and I'm gonna put something on the screen. So this is something I tweeted a long time ago now. It feels like it was yesterday. How long does it take between changing a line of code and that code running in your development cluster? So most people said 30 minutes, which I think is pretty sad. A lot of people said 1 minute, which is okay. And very few people said 2 seconds. Um, I assume you have thoughts about this, strong ones.
I
Would you
do.
like to share?
I actually have an epic rant that I'm going to cut short for this one. But the TLDR is that probably one of the biggest differences I've noticed between your we'll call them a 10x engineer, and a average engineer is the amount of time that it takes for someone to see the changes to their code happen. If you think about a REPL or something like that, it's all about learning. The faster that you can learn something, the faster you can figure out how to move on to the next bit. And so uh, getting your cycle time down to the minimum possible is one of the most important things for productivity, in my opinion. And at 30 minutes, if you're sitting there waiting for it to go through a CI pipeline, it goes from something where you can actually get like real responsive feedback from to, you've got to figure out what in the world is happening and how to pull it all together. And so I obsess over seconds of cycle time.
Yeah, the way I always explain this is in terms of cognitive cost. So if you have time to pick up your phone and look at cat memes, now your brain's full of cat memes and it doesn't know what your code does anymore. And then you lost your train of thought, and that's going to be expensive in terms of cognitive effort to gain back. So ideally, you have no breaks. You don't have to type kubectl apply, Docker push and whatever every time you make a change. Ideally, you don't do any of that. You just keep that context of the code in your head the whole time, and then it's a breeze. Then you never lose focus. But if every time you make a change you need to wait, and then you're browsing memes, blah blah blah, it's gonna be exhausting, because context switching, I don't think human brains are very good at.
It's really interesting, and not just the looking at cat memes and the rest of that, but the other side of it is I've noticed, I'm going to call it architecture astronauting, where if you've got to wait 30 minutes for a build, you spend your whole day double checking and triple checking to try and make sure that that piece of code is going to be perfect without actually having any clue what will happen. And so
Yeah.
I find that the build times also increase the bike shed conversations infinitely.
Yeah. I mean, if you have 30 minutes to sit around, might as well argue with your colleagues, right?
Exactly right. Or as the canonical XKCD comic,
Yeah.
go and do some jousting while you wait for build times.
Yeah, that's fun. All right, so I'm gonna get down to the nitty gritty and show everyone what we're gonna do today. Streaming buttons are hard. Where's that button? Here. Uh-oh, something went wrong. This is bad. There was supposed to be code on the screen. Let me pull a cable and put it back on and see if it works. Um. Nope, it did not work. Okay, we're having technical difficulties. We will be back momentarily. Okay, everyone, we are back. I am very sorry. Computers are hard, as you all know. And if you want to know the story, it's because everything is going into the same computer right now. So there's the thing capturing this computer that's on the screen. There's the camera. There was a teleprompter, but it just shut down. And this computer has a tendency to, when you plug in too many USB things, it thinks that the whole thing has shorted and it's going to explode, and then it deactivates all USB. So that's what just happened. And usually you have to restart. This time I didn't have to restart, so that's happy. But it's also scary. Okay, where were we? Right, I was gonna show you all what we are going to do. That was ever so slightly stressful. Okay, so this stuff that's on the screen, this is tilt, and this is, well, that doesn't matter right now. I want to show you something. Oh, there's errors here too. So both computers are screwing up on me. So this is not going to work, is it? Let's see. What software do you use for streaming? Adam says. I use OBS, the same as all the gamers. All right, so this thing we have on the screen right now, so let me reset this. This is it's an example app that we use for tilt. And it's basically an app that does image filters. So here I select an image and I can add the color filter, or I can add the glitch filter, or I can add an object filter. And this is like some machine learning stuff that's going to tell me what is it that is on the images. So here it says person and teddy bear. So this is an example app, and it contains a ton of services. And they are all of these things here. So there's a glitch service, the red service, because the color used to be red, so we called it red. There's a rectangular, which is the name for the service that puts the square there with the name of the objects. Storage, Muxer. This is Max Object Detector is the actual machine learning thing, and this is just some container I got from somewhere. Front end, and then Flush Database, it's just a utility, so this is not a service. Benchmark is also a function, not a service. So basically from here below, I have functions, basically buttons, and from here up, I have services. We are working on the interface to make them more differentiable, but that's how it works right now. I'm getting some errors here. I don't know what they are. I'm going to restart Tilt and see if it goes away. So we have this app and we have all of these services. So what are we going to do? So Tilt is a tool that's going to basically monitor my code for changes. Whenever I make a change, it's going to update my app. And update my app can mean different things. It can do something like Ksync does, or it can do other things. And we're going to basically start with the initial workflow that everyone does when they're getting started with microservices. And that's slow. And then we're going to apply slowly hacks upon hacks upon hacks upon hacks. And in the end, it's going to be really, really fast, and it's going to be basically instant. So I want to show you all of that. And I'm looking forward to Thomas's thoughts on all the stuff that we do. And I hope we don't get any more computer trouble. Because I mean, fixing Kubernetes is kind of easy. The problem is if the USB port goes out, what the hell do? I can fix Kubernetes. I can't fix the USB port.
Microsoft just pulled a underwater data center out of the ocean. And I had the thought when they pulled it out, man, I would not want to debug a water leak in that sucker.
Yeah. Also, I wouldn't be the person who they put the blame on because of the water leak. Okay, so what's going on the screen right now? I have two instances of Tilt. As you can see, this is one instance and this is the other instance, and they are not the same. So this one on the left is a local cluster. This is running on microcates on my computer. And the one on the right is a remote cluster, and it's running on Google Cloud. So we're going to do all these benchmarks twice every time. Once locally on microcates and once remotely on Google. On the things that are heavy on network, like downloading stuff, the times tend to vary a lot. So like it can be 30 seconds now and it's going to be 1 minute the next time. So we're going to have to be a bit approximate here. The stuff that runs locally or that depends on compile time or stuff like that, that's usually more consistent. But I'll let y'all know once things are going on, once these things are going on. So we have an error here. I have no idea what this is. IO timeout. Kill pod sandbox. I have zero clue what this is. Failed to create. I've never seen this error in my life. So remember when I said, oh, I hope you don't get any more computer trouble? We got more computer trouble. I'm going to restart microcates and see if that works, but restarting microcates takes forever. Failed to create pod. Failed to set up network. I have no clue what this is. Okay, I'm gonna restart microcates and let's see what's going on. So microcates, stop. And let's see if this works. And if it doesn't work, then we just do the remote version and I'll just tell you the numbers for the local version because we've had one problem too many already. So I'm gonna give you something. Let's do something here. Oh, we got more errors. Jesus Christ. This is like it's the Spanish Inquisition all over again. Okay, so once something is done happening, then this is gonna get more entertaining, I hope.
I don't know. It's pretty entertaining so far.
Yeah? Well, I hope our other 18 viewers that are currently online agree. Okay. Is this running already? Demo gods. Yes, Adam, it's the demo gods. So that's why I like live coding, because when it's just live coding, it's all on me. I control what's going on. When it's a live demo and they're separate things, then I depend on computers, machines, things, and that is scary. So maybe I should do more live coding in the future and less live demoing.
Or even worse, live demos rely on past Thomas. And let me tell you, past Thomas is a jerk.
Oh, yeah. Yeah. I mean, I haven't met past Thomas. We just met like 2 days ago. But yeah.
No, you'll have to take my word for it. He's very insensitive.
Yeah. Well, James is looking at cat memes, James Kitson. So that's good. Also, it's funny that James. It's funny that your surname is Kitson because Kit is cat in Ukrainian. So that's fitting. Do you speak Ukrainian? Okay, so I have something that I can show you on the screen right now. So I have this, the remote version here is running, and I'm going to click benchmark. And I'll explain the mechanics of this later, but this is going to tell us, like, down to the nanosecond, how long it took from code change to the new code being running on my cluster live. And we'll see how long that takes. Spoiler, it's going to be a long time because this first version is the noob version of it. So,
What is the first version? Are you just building the Docker image then and reloading it entirely?
I'm going to show you how long it takes, and then I want you to guess. We have some more comments. Dan Bentley, that jerk, he says future Thomas is a freeloader relying so much on both present and past Thomas. Yeah.
It's true.
Yep.
Future Thomas stands on the shoulder of giants.
Yeah. Oleg asks, do you speak German? Do you speak Russian, actually? Okay, how do I reply to that in Russian? Я не понимаю по-русски. Yeah, I think that's all I can say off the top of my head. Okay, and we're getting a billion errors. If we go back to here, the local. Oh, right. Does anyone know how to fix this bug with the microcates registry? Because every time this happens, I need to restart the computer. Because I don't know how to get rid of this. So let's look at the remote version for now. So it took 1 minute and 37 seconds to reload a service that does basically nothing. What do you think we're doing here, Thomas?
I mean, I'm reasonably sure that it's a complete rebuild and manifest update and restart of the pod.
Yep, and we're
But
downloading all dependencies every single time. So let's ignore the local version for now. I'm just going to tell you what the local version would do. Let's just do the remote version. If someone figures out how to fix the local registry microcates thingy while I do this, let me know. I'm not going to try to debug it live. So let's just do the remote version. So I'm gonna show you all everything that's going on here. So wait, too many keyboards. Here, right. So let's start with the Docker file. What's going on here is every time we make a change, Tilt notices the change and it redoes all this. It rebuilds this image. So this image, it's an Alpine image, so it's not a very tiny image. It has a bunch of stuff. Jerome says we are being entertained. Please keep the live demoing thing going. Yes, I'm trying. It's hard, okay? And AJ says live debugging is even more interesting than live coding. Yes, but it's stressful for the person on the camera, damn it. So basically here, the most glaring omission here is we're not doing any caching at all. So we're basically downloading API machinery from scratch as a dependency every time we rebuild it. And we're rebuilding the whole image, and we're putting the whole image into the cluster. And this is a remote cluster, so it takes time to upload. Now let me show you something else. This is the tilt file, and this is basically, you can think of it in this context as a huge bash script that it's actually Python that gets run every time a change happens. So what I'm doing here is things to note here. I have my glitch service. It monitors basically the dot folder. My Docker file is the glitch.docker file, and that is this one that we just saw. I'm monitoring these directories, and I left vendor here. I shouldn't, but it makes no difference right now. Abdullah says, woohoo, Tilt. Yes, we miss you, Abdullah. Abdullah used to work with us at Tilt as an intern, so that was cool. And what else is going on here? We have a benchmark script, and when I pressed benchmark before, it ran my generate start .shell file. So let's see what that is. Generate start. So generate start, it injects this Go file into the service, and this Go file has a benchmark function that basically bash is giving this file an updated timestamp of the time when the script ran. So for example, the last time I clicked benchmark, the code got this timestamp. And then I do the subtraction later here. And once the code runs, I can tell the difference between the time when I click the button benchmark and the time when the code is actually running. And that's going to give me a very accurate benchmark of how long it took between me applying a code change and that code running. Do you find this cool, Thomas? Because when I learned about this, I found it cool as hell.
I was like, when I saw you go and hit the benchmark, I immediately wanted to ask you how you were doing it. I'm so glad that you got there. This is awesome.
Yeah. So this is basically, I stole some ideas from some people, and then I added a bit of ideas of my own, and then we came up with this. I love this. I do this for everything. Like every personal hobby project I'm running, I'm benchmarking things with this.
I
Okay.
want to see a GitHub button on people's READMEs to say how fast their cycle time is now. Someone needs to go put that together.
That is a really cool idea. Yes. Yes, let's do that. Uh,
Yes, I'm in.
that should be a Tilt extension. We have Tilt people on the chat. Can you please write it down? Let's talk about it on Monday. Okay. So we did run a benchmark, and I'm gonna flush my database to get rid of this error. What's going on here? Why are these things not running? Tracking pod rollout. What's going on? Oh, is this working now? Apparently this is working. Okay, apparently one thing spontaneously broke and the other thing spontaneously started working. I love computers. Okay, let me try to benchmark again and see if this is gonna run okay locally. And let me dismiss. I can't dismiss the other error. Well, we're just gonna have a red thing on. Actually, there you go. Now the error is gone. So we're rebuilding the glitch service, and it's going to take forever because it's rebuilding the image, it's re-downloading the dependencies, etc., etc., etc. So let's just let it finish running one more time, and then we're going to start optimizing this.
So I noticed that you've got your Docker image with the Go mod after copying the code. Is one of your optimizations going to be to switch those two so that you can get a little bit more of the caching?
I had to go mod.
Am I jumping ahead?
Yeah, you're jumping ahead. Where was that? On the Docker file?
Yeah, in the Docker file.
Oh, yeah.
If you just swap line 3 and 4 there.
Yeah, that's the first up. We're gonna get there in a second.
Okay. Okay, good.
Okay, so here 1 minute locally and remotely. Yeah, it's still thinking. I'm not gonna wait. It's gonna be a minute and a half or so. So there are two ways to optimize. So the thing that is taking the most time here, which is actually not on the screen right now, but what takes the most time here is this. It's downloading all the dependencies again every single time. So we're going to get rid of that. We're going to make it download dependencies once and not think about them again until we change them. So there are two ways to do that. There's my preferred way, and there's the way we're going to try first. So this was suggested to me by Dave Cheney, and depending on what you're doing, it makes more sense than what I'm going to show you next, but it's not my favorite, but I'm going to show you anyway. So you do go mod download, and you do that before you copy your code so that you can change your code, but this is all the dependencies are still going to be cached on Docker layers. And if you are not, if you don't understand what this is exactly, you can talk to Jerome. He's on the chat right now, and he's an expert teacher of Docker stuff. So you can ask him to teach you and your company. I should have an affiliate link for this. Anyway, wait, I messed up. Okay, wait, there's no /go. There should be a /go. What the hell just happened? Where's /go? There's no /go. Oh, yeah. It's run. It's not copy. Okay. All right. So the first time, it's going to take exactly as much time as it did before because there's nothing cached. Then we're going to run this again, and it's going to be faster because it's already cached. Or so we hope. We're going to see what happens. Are we taking bets?
My bet is that it's going to be cached.
It's going to be
as long as you don't touch Go mod.
It's going to be cached. Is it going to be faster?
Well, of course it's going to be faster.
By a lot or a little?
Does it include the client Go? Because if it's client Go, then it's going to be infinitely faster. But if it's just, including gRPC Go or something like that, then it won't be much faster.
I have API machinery.
Yep. That's a middle ground. So it'll be moderately faster.
Okay.
I foolishly tried to check out Kubernetes/Kubernetes one time.
Oh yeah.
Without doing a shallow clone. It was not my brightest life decision.
Yeah. When I did my internship with doing work on kubectl, I think my Kubernetes folder was like 5 gigs.
Yeah, it sounds about right.
And I was in Brazil, and internet there was not very good at the time. So yeah, that was a fun couple hours. Especially when downloading with something like what's it called, Go Get, because it doesn't give you a status.
Oh yeah, you just sit there and hope.
Uh-huh. Yeah.
uh,
Okay, so let's just continue here. So both have finished their first update, and this benchmark is wrong because we didn't click the benchmark button, we just changed the code. So now I'm going to click the benchmark button, and I'm hoping it's going to be like 30 seconds local and around 40-50 seconds remote, but we'll see. And let me put on the screen. I used to present this as a talk. So, okay, this was the basic, the initial setup before. The internet, the connection I'm using now is a bit worse, so it's taking longer. And, okay, let's not look at it just yet.
What instances are you using for the remote cluster?
I have no idea. You can ask Dan Bentley, who I think is watching, and he can tell you. Dan, what's our cluster like? Okay, so locally, 30 seconds. So if we had bet, I would have won an amount of something valuable. Meanwhile, the remote cluster, still working. Okay, 1 minute 14. So both were a bit faster. And in previous tests, these were the numbers. So 50% faster locally, 73% faster. Wait, no. 50% of the initial time locally, 73% of the initial time on a remote cluster. So it's faster. And if you do vendoring, if you do like Go mod vendor and then you sync your vendor directory, actually let's do that first and then I'm going to compare the two. So we're going to do the same thing, but instead of caching things with Docker, we're going to cache things with files on your file system. So let's see if that works. While I type this, Thomas, do you have any strong thoughts?
Wait, you mean you're going to use files on a file system to cache things? It's crazy.
I know.
I don't honestly think it's going to be much faster. I'm excited to see what the percentage difference is there. Something important to talk about while you're doing this, though, is that these numbers are pretty dependent on Go itself as a language. If you did this with something like JavaScript, for example, you'd see that the caching would significantly would provide a much larger speed up because you don't have to do the actual compilation phase for a JavaScript kind of application.
Yeah. Oh yeah, that's an important point. All of this stuff that we're seeing today is for Go, and usually at the end, when I present this stuff at the end, everyone's like, "Oh, what it's like for Python, what it's like for Java, etc." And then like, okay, then we discuss those, but like, there's so many different variables. So like, this is the stuff for Go. For other languages, the conversation is slightly different.
I still think that the methods apply 100%. It's just that you'll get different numbers is maybe the best way to look at it.
Yeah, and as we go further into the subject, we're gonna have more caveats that apply differently. So I don't want to spoil things right now, but for example, no, I'm not gonna say anything. Let's wait a minute. We're gonna see it soon enough. Okay, so we are almost done. Okay, we're done with the initial deploy, so now everything should be cached, and I'm gonna run it again, and now we're gonna see how long it takes for real. And then I'm gonna tell you why I prefer doing copy vendor as opposed to using a Docker layer as our vendor in cache. So things are happening here.
I'm very excited to hear the reason why you prefer this. I've always done it with layer cache, if I'm honest.
Okay, so here we have 32. So this took 3 seconds more than the previous method. And we're not going to wait for this guy. I'm going to start talking. So, why do I prefer this? Because if you have 10 dependencies and they are big, like API machinery kind of big, if you change one dependency and you are copying your vendor directory, that's all you need to update. The one thing that you changed. If you're caching, if you have a 1 GB layer on your Docker image and you change one dependency, that whole 1 GB is gone. And you have to
But you do
download.
need to introduce, so this method really only works super well with the tilt file though, because you can run the vendor update locally and then do the copy.
Yes.
Right? Like if you were just keeping this purely in Docker land, you'd have to have something that would go update your local vendor, or else it would get
Yes.
out of sync eventually.
Yes. Yeah. Yeah. That's a very good observation. Yeah. So 1 minute, basically, I think there was no difference here then, and this took a bit longer. So copying the vendor directory takes a tiny bit longer, but you can save. If you change one dependency, you can just update your vendor directory and you just get the new dependency, and that's going to be faster than if you have to scrap all your dependency cache and download the whole thing again. So that's why I prefer this. But I mean, both can work, just kind of depends on what you're doing. Like if you're developing remotely only, I mean, the time it's going to take a Google cluster to download a bunch of dependencies again, it's nothing. So that also doesn't matter. So maybe this applies more to local development than remote. But yeah.
Also, a remote Docker build host, the copy would require uploading all of your vendor to the remote build host.
Can you explain that?
So if you were using like BuildX or something like that, then copying vendor would go pretty slow.
Oh, yeah. Yeah.
Because it would have to bundle up the context and ship that whole sucker.
Oh, and it doesn't cache it by parts? Oh, okay,
No.
so it's basically like a Docker layer then.
Oh, it's even worse than that. It'll have to tarball your entire build directory and ship it over to the build host. And then the build host will have to extract it, and then you'll get the benefits.
That sounds like it takes way too many seconds.
way too many seconds.
Yeah.
Because we're trying to get under 2 seconds, right?
Yeah. Okay. So I'm not happy with this. This takes too long. So Thomas, creator of Ksync, what would you do to make this faster?
Oh man, do you want to go through the slow steps, or do you want to just jump to the end for the solution that I like?
Let's go with the solution that you like.
Okay, so container builds are slow. Like if we go talk about Python or Go or anything, container build process just takes time. Like even if you have hyper optimized the layers, you figured out how everything fits together, it just takes a while. Whereas like if I'm running a Python or a JavaScript again, I could just restart the process and suddenly get all of my new code going. So what Ksync does is it's a bidirectional sync from your local directory to the remote container. So it just syncs the code over and then reloads the process for you. So for process or a language, your camera just kicked out, by the way. For a language like Python or JavaScript that are interpreted, you can hot reload easily. With a language like Go, you only need to do the compile. You don't need to go and have anything else happen as part of the process. And so it speeds everything up quite a bit more purely by getting that extra layer out. Like Docker is amazing. I need it every day. But there's a bunch of things you can optimize by jumping into the container itself.
So what you're saying is we should stop building containers every time.
We should stop building containers every time. That said, with BuildX, there's some interesting fun things you can do with actual build caching to speed that up as well. But back in the days of Ksync without build caching, going directly to the container and running it there was the best solution that we had.
Okay, I don't know about the fancy thing you mentioned, but let's go with the let's go with not building a container every time. Let's see what happens there. So how do we do this? we want to stop creating a new container every time we make a change. We want to sync some code with a container and then rebuild stuff inside the container. So I'm gonna go back to my tilt file that, like I explained, it's basically a big bash file that runs every time a change happens. And okay, so I'm gonna, tilt has this thing called live update, right? And so we're gonna use that. So I'm gonna live update, and I'm gonna do that by syncing, and I'm gonna sync my glitch directory, I think. I'm trying to look at my notes, actually. I'm trying to cheat and look at my notes, but they're too tiny, so I can't see. And I'm gonna sync that with, let's say, app glitch on my container. Okay, so basically whenever I change anything, it's going to whenever I change anything inside whenever I change anything inside this directory, inside my glitch service, it's going to update that on the container. But if I have something running on the container and I change some dead files on the container, nothing's going to happen. So I'm going to need something in the container that's going to say, oh, hey, there was a change here. I need to recompile. So first, I'm going to need a recompile script to leave there. And second, I'm going to need something to detect when changes happen so that it can run the recompile script. So let's do that and see what happens. So I'm going to save.
So this is,
yeah.
So this is a pretty big trade-off between the two that's probably worth calling out, that because we're now doing the build inside the container, there's a little bit more tooling required. Like we need a Go compiler inside the container and some other little stuff like that. Personally, it's worth it, but it's something to be aware of.
Yeah, we're gonna get rid of that later. We don't need tooling inside the container. That's silly. But for now we do. Let's just see what happens now. Okay, so I think this is all we need to do on this file. We're gonna need to update our Docker file. So I'm gonna do glitch.dockerfile. So okay, I'm gonna need something here. I'm gonna need enter. Enter is a thing that's going to detect file changes, and once it detects a file change, it's going to run a script, and that's going to be my recompilation script. So we can get rid of this, I think, and we can get rid of this, and oops, no. And instead we can do, we're going to list files inside my glitch directory with the Go extension. We're going to give this list to enter, and it's going to restart the recompile script. I think that's all I need to do. Does this make sense to you?
Yeah, it sounds like it's been a little while since I've used enter, but that sounds right to me.
What do you use?
Tilt, obviously.
But if you're trying to sync,
just
sync the source
I've been using watch exec.
Okay.
Which is a little Rust program that does it. I stopped using enter because I had issues with, man, I don't even remember, but watch exec worked a little bit better for me than enter did at the time.
Okay. Okay, I forgot to delete this file the last time that I ran through this, so it's already here, so I'm not going to type it live for you, I'm sorry. But basically, this is the script that we're going to call inside the container. It's going to rebuild my file, basically, my Go executable, and rerun it. So let's see if this is going to work. Let's try it. Nope, recompile.shell, no such file or directory. What do I need to do here? Did I do something wrong? I probably did something wrong. Oh, right, yeah, okay, so, yes, here it's inside the glitch directory. Glitch. Jerome says, why did this not update?
It's watch exec. Let me drop a link in.
Okay, wait. I want. Strange, because I see a comment over there and I don't see the comment here on the screen. How do I
And I'm
force
pretty
it?
sure the reason I ended up using that was that Enter has got some issues with daemonizing processes that watch exec
Oh,
doesn't have.
I see.
I was
Okay,
doing some crazy curses stuff that Enter had a tough time
got
handling.
it. Yeah. Oh, I see what you mean. Got it. Yeah, okay. So Jerome says, what was the name of the tool that you use instead of enter again? Can you type it on the chat so it's easier for people to copy and paste?
Yep, I dropped a link into the chat.
I don't. Is it our chat on Zoom?
No, I dropped it into the YouTube. Oh, I dropped it into top chat. Let me drop it into live chat and see what happens.
Okay. All right.
I
I'm gonna
don't know
go.
how to YouTube.
Yeah, YouTube is hard. So going back to the code here, I just finished fixing this. So let's see what happens next. Watch exec. Cool. So if anyone is waiting for it here, there you go. Watch exec. Okay, so we're gonna wait for the first run. And then I'm gonna click benchmark and we're gonna get the exact time it took. Okay, almost there. I need to come up with some jokes to say while these things update.
Or, since we're simulating this, just pull up some cat memes. Walk us through the top cat
Oh,
memes of the internet for the day.
right. Okay, so I'm gonna click benchmark. Let's see what happens. Okay, it restarted in 1.6 seconds running locally and in 4.3 seconds running remotely. I think this is a tiny bit faster than the 1 minute it took before.
Just a little bit.
A little bit, yes. Okay. Now, what do you think of this workflow? Is this your favorite?
This is my favorite. Probably the biggest downside to this, like I mentioned earlier, is that you kind of have to have a special pod just for development or a special container just for development. And I usually do a base container and a separate development container. And so it works. It just is kind of painful to do it.
So what you're
Um,
saying is that if this container is not special, if it is just a cheap container that can't do much, it's gonna take forever. Is that what you're saying?
no, I was actually talking about the image, but that also is a problem. If you go and put any kind of limits on there, it's going to go real slow on that cluster.
Okay, so while this redoes its thing, can you explain what you actually meant? Because I totally missed it.
Okay, so if you're doing builds inside of a container, you have to have the compiler there. You need to have enter,
Mm-hmm.
and you don't want to ship those with your normal container image.
Yeah.
And so what you end up doing is having two separate Docker files.
Mm-hmm.
You have a base Docker file that goes and builds the, we'll call it production container, and then you've got a dev Docker file that inherits off of that and builds your dev environment that goes and runs in it.
Mm-hmm.
And it's not awful, it's just something that you need to pay attention to, that your dev
Mm-hmm.
container ends up being what doesn't run in production, kind of
Mm-hmm.
chunky and slow.
Yeah. Okay, so both local and remote are compiling. I'm not even gonna run this again later because I think at this point we can see how longer it takes. And that's actually an important point that I'm trying to put across here. It's that if you have enough compute inside the container, you can just do everything inside the container. It's fine. But if you have 50 microservices and they're all very skinny, very light, and they don't have a lot of power, then compiling something in there, it's going to be either very slow or impossible. Because if you don't have enough memory, it's just impossible. If you don't have enough processing, you're going to need a lot of patience. But anyway, this is the reason why this is not my favorite workflow either. And I'm going to show you how to fix this in a minute. So yeah, this took forever. This was actually faster because I think processors are better on Google than on my computer. So a 0.2 processor compiles faster at Google than a 0.2 processor in my laptop. And Jerome's talking to us. Let's see what Jerome's saying. Jerome's saying, in this show, we don't say enhance while watching video surveillance footage, but this is taking way too many nanoseconds while tailing build logs, and I think this is beautiful. You're a poet, Jerome. You're a poet. You need to tweet this right now. Hold up. Can we have 2 containers in the pod and put the executable in a shared volume?
Yep.
That sounds like a smart idea, and I'm tired right now, so I'm gonna go with yes, that sounds amazing, but I don't really understand. When I watch the recording again, I'll write you a reply.
The downside with that one is that you end up starting to do crazy templating things with Kubernetes because you want to have a dev container that gets turned on and off. I go around that with ksync by doing some hacks that are not good and no one should do. But if you've got full control of the manifest, it's actually pretty easy. Imagine a customized template that just goes and adds your build container in.
Oh yeah, that's clever. I like that idea. I'm gonna investigate that. Okay, now coming back here, let's try something else. So the problem we ran into here is that if you don't have enough power in the container, that's gonna make it slow. So how do you do it so that you don't depend on how powerful your container is, but you can still live reload stuff as opposed to rebuild the image every time? Can you think of something, Thomas?
I'm super interested to see where you're going here because the naive one is to just build it all locally on your laptop or desktop and then ship it over, which is awesome. The question I've got in my mind though is I hate maintaining local and coding environments. And so I do all of my builds inside of containers just because I've been, let's say it, burnt by Python and Node having different versions. And so I'm super interested to see where you go with this one.
I think the difference here is that once you build an executable, who cares which version of Go that is? You put the executable in an Alpine container, it's going to run.
I care about what version of Go I'm running on my local system. Because let's just say that the Go 115 cert changes have burnt me a little bit. And so some projects I'm working on now use Go 115 and other ones use Go 114. And so I have to actually pick which version of Go I'm using because of that.
That is something I had not thought about. So something I just want to tell everyone here is I'm doing basically this content for a GopherCon talk that I need to record in the next couple of weeks for, I think it's called GopherCon. I don't know. It's a virtual GopherCon, the next one. And I was like, I was going to prepare the talk, and I'm happy to do a talk at GopherCon, but I was kind of sad because I'm like, I already presented this a bunch of times with this whole Corona thing. I just did this talk online 100 times. So I need something new for GopherCon. I can't just do the same thing because like GopherCon, it's like my favorite conference. GopherCon is special. I need to make something cool. And so my secret plan in this stream was to ask Thomas a bunch of questions so that he would give me ideas for how to make this talk different for the GopherCon version. And I'm very happy because there's been so many ideas, and I'm going to try all of these things, and then I'm going to make the GopherCon talk really cool.
So Jerome has got a question that is going to be even cooler.
let's move to the comments. Or ephemeral containers, they're in alpha. Okay, seriously, don't pay attention to my rambling. Ooh, we're already paying attention. You're on camera, Jerome. Everyone is seeing you. The whole internet is seeing your rambling. Uh,
So
I don't
if you
even know what
contain,
ephemeral. I don't even know what they're
uh,
for. Can you explain that?
yeah, so ephemeral
Actually,
containers are
sorry.
super cool.
Let's just do something. I'm gonna start writing code for the next thing we're gonna do, and while I do that, you explain so we don't have to wait later.
Awesome. That sounds like a great idea. So ephemeral containers are super duper cool. Imagine running a service in production and needing to go and do debugging on it, but you can't restart the process. Ephemeral containers make it so you can just add a container into a pod on a per pod basis so that you can go and do debugging. So you could theoretically bring your entire like dev toolkit along with you, pop it into the pod that you want to debug, go run whatever you want to do in there, and figure out what's going wrong. Super duper cool. Once you can add the shared process namespace to ephemeral containers, that's when everything starts to go crazy and just be insanely cool, because the shared process namespace gives you full access to all of the processes and all of the file system of every container in the pod. And so now you can go and do file syncs where you can have a super lightweight scratch-based Go container with just the binary in it, and you can do all of this hot reloading and dev rebuilding.
I was gonna write code while you talk, but that's interesting. Now I
It's
understand.
super cool.
Now I understand why all of Twitter was saying that these are a security nightmare.
Oh, insanely security nightmare.
Cause,
You have to
cause
have the PSP locked down on it because it's as bad or worse than doing a privileged container.
yeah, it's worse. Cause you're saying I can change whatever I want in the container that's actually running while it's running.
Yep. Yep.
I love this. It's a train wreck, and I love it. um, okay, now that's something. Hmm. Okay, I have so many things that I want to just go and Google right now. All right, let's wait. No, wrong screen. Let's come back to our code and try to do the thing. And I realized that I need to explain this while I do it, else it makes no sense. So let's just do that now. I'm gonna go to my Docker file first. And basically, what I'm gonna do is I'm gonna recompile locally, and I'm gonna put that binary in the container and restart it. So I don't need tooling in my container anymore because I'm not compiling inside the container. I don't need any of this code anymore because I'm not gonna, I don't need code, I just need a binary. So I can just do add. Can I find this in my notes? What do I need to add? I think I need to add glitch/main into app/main. And then enter is just gonna monitor my main file. So this is kind of a silly line of code, but whatever. And then I'm just gonna run my main file. Okay, now I need something that detects changes locally and recompiles things locally. So let's go to my tilt file, and that is my basically bash script that's actually Python. And what am I gonna? Okay, first, I don't need to sync any of this stuff here. All I need is glitch/main. That's all I need. I only need to be concerned with one file here. The rest is stuff that's gonna run locally. They're not part of my service. What I'm gonna sync here is no longer a directory, it's just a file. And once again, I'm just putting it there in my file system inside the container. So this is local, and this is inside the container. So if I come down here, so I'm gonna do another local resource, and that's basically something that's gonna run locally when something happens. So let's do local resource. I'm gonna call this recompiler, and this is gonna be basically the recompiler.shell that I had before, and it was running in the container, but now I'm gonna recompile locally. So I'm basically transferring that functionality back to my computer. So what am I gonna, what do I need to do here? I need to do, um, you know what? There's something we need to do. I'm not gonna do it. I'm gonna let it crash so we can see what happens. So I'm gonna do go, I think Jerome knows what it is already. I'm gonna do go build. I'm gonna output this to glitch slash main, and it's gonna come from compiling the glitch directory. I think this is it. I'm gonna use double quotes here, and you're gonna understand why soon. And this is gonna be monitoring. This is not something you would do in production because you're changing many Go files, but for now we're only gonna be changing one, so I'm just gonna take a shortcut here, and I'm only gonna be monitoring the file with my timestamp. So I think this is it. Let me check my notes. Am I missing something? No, I don't think I'm missing anything. Let's see if this is gonna work. No, there is no main file. Huh. Okay. What do you mean there's no /main? This is probably Dockerfile. This is probably Dockerfile troubles. Was it this? I don't think it was this. Let's see. Nope, that file is not there. Do I need to restart the container because things? Sometimes that's what you have to do. By the way, let's not ignore the fact that Jerome is singing. Does anyone know that? Do you know the song that he's referring to here?
I wish I knew the tune. All I was doing was just singing "sinking" in the back of my head.
Yeah.
That doesn't actually count for a popular song.
Hey Jerome, do you want to call me on the phone and sing the thing, and I'll put it on the microphone for the stream? Uh, let's see if Jerome replies. Okay, I'm still missing something here. I don't know what it is. Do I not have? No, I do have a main file there. Well, I'm gonna do the very lame debugging that I always do when my Docker stuff goes wrong. I'm just gonna start adding shell commands here until I can figure out what went wrong. What is wrong here? I have no idea. Okay, this didn't run, so it was not this. Is it the syncing? It might be the syncing. Let's check my tilt file. Okay, my recompiler is running fine, I believe. So if I do here, if I click the benchmark, recompiler is going to run, and I'm going to end up with a new binary. Is that right? Yes, it's a new binary. So recompiler is working. Maybe the issue is the syncing. Maybe I'm doing the syncing wrong. Let's see. Glitch.main. Oh boy. Syncing in the rain. Yeah, I can see that.
It works for me. I could do a little tap dance in the rain.
Yeah. Huh. Jerome, I think you need to record this for us. I think you need to share this. All right, let's go back to debugging. I don't know what I'm doing wrong here, actually. Yep, I legit have no idea what's. Oh, is that? Yes, I think I see. Yeah, okay. is it this? Because this sounds very silly. Nope. Wait, there's no... No, that was not... Do you have any idea what I'm doing wrong? I have no idea what I'm doing wrong.
So it's saying that it can't find the executable.
Yeah.
Is it, did you take a look at the tilt sync? Is the binary actually getting built?
It's getting built. That I know for sure. Let's see if it's getting synced. File changed. Oh. Could it be the... Could it be... No, but this is working. So this is running. I'm sure this is running. I am rebuilding glitch/main for sure. Oh, remember when I said I'm gonna make it wrong just to show you how wrong this is? So I just tripped myself on the bug that I wanted to show you. Ah, yeah. I wish I had done this on purpose, man. Wow. Wow. Yeah. Okay, so let me show you something, and this is gonna... I swear to God, this was not on purpose. It's gonna be on purpose for GopherCon. Okay, so I tweeted this a long time ago. You see that a file is there. You try to run it, and it says not found. And the actual problem is that it's a dynamic library problem, like Jerome just explained. Could the issue be that no such file or directory is actually a dynamic library problem? And yes, it is. And actually, you should, if you're watching this, you should go read Jerome's explanation of why this happens. I'm going to share a link for this at the end. So I'm not going to explain why this happens, but the thing is, if you're using shared dynamic libraries, things are going to be broken unless you really know what you're doing. I don't, so I'm not going to use shared libraries. I'm just going to come here and I'm going to say cgo enabled equals 0, and that's going to fix my problem. I can't believe I fell for my own trap, man. That is like next level. Okay, so back here. I think I forgot to share the screen. I just added cgo enabled equals 0. And now everything is running. So I'm gonna, is this up and running? Yes. So now I'm gonna benchmark. And locally it took 2.78 seconds, and remotely it's still copying the binary because it's a big fucking binary. Sorry, I said a bad word. It's a big fracking binary. Yeah, and this Wi-Fi is really bad, so it...
Lost your camera.
Hello, I have returned. Okay, now let's shave down this time, because 22 seconds is a lot. So locally it doesn't matter, because I'm basically copying files inside my computer. But if I'm using a remote cluster, I want this time to be as small as possible. So 22 seconds is a lot. Let's make that smaller. So if we look at the size of our file, and that is the main issue, it's copying the file. That's our only bottleneck left now. It's 15 megabytes. That's a lot. Yes, like Jerome says, it's a big honking binary. So what can we do? One thing that we can do is, if you look up the internet, how to optimize my Go binary something, first thing you're gonna find is remove debugging artifacts because they're very big. Everyone says that. Usually that advice is useless, but in this specific case, it's actually good. So let's do that. So the way to remove debugging artifacts in Go is to pass this to the compiler. And that's why I'm using double quotes here, because I knew I was going to need a single quote here. So let's see how long that takes now. Let me wait for this one to finish, and then we do it again.
How much does gzip compress the binary? Am I jumping ahead?
No, we're not going to use gzip. I'm going to use another. I'm going to use a binary compressor in a second. So
Cool.
We're going to look at that next. Okay, so let's benchmark again. And locally, 1.9 seconds. Even got faster locally. That is kind of impressive. And remotely, let's see. Let's see how big it is now. Now it is 12 megabytes. So we went from 15 to 12. That is significant. And 16 seconds. So before it was like 22 or so. Now it's 16. That's a lot better. And then there's one last step that we can do, and we can use the universal packer for executables, and that is UPX. So whenever I mention this to people, everyone always says, oh, but when you transmit packets through the network, they get gunzipped, and so there's no point in compressing things further. If you use WinRAR, how do you pronounce that in English? Actually, it sounds
WinRAR.
Yeah, if you try to use WinRAR on a .exe file, it's not going to compress anything because the binary is already compressed, and blah blah blah. And people give me 100 billion reasons, and I just have to say you're all wrong. It works. So let me show you how. So I'm gonna need to copy some instructions here. Okay. So I'm gonna just do some things here. I'm gonna say here echo recompiling just to make this pretty. And then we're doing this big mess here. Here, let's do something else. So this is not going to be main anymore. This is going to be a big binary. So let's rename it big. Then I'm going to do, oops, nope, no, wait, big, okay. So now I'm going to do UPX glitch slash big dash o glitch slash main. Is that what I should do? No, let's do different. Let's just do this, and I'm going to pass a couple arguments here, and then I'm just going to rename it to glitch move glitch slash big to glitch slash main. Let's see if this works. And now we should see UPX in action. Hopefully, maybe. Did it run? I don't think it ran. Did it run? No, it didn't. Okay, let's see. Benchmark. All right, I think what I want to show you. Nope, failed. Something failed. What went wrong here? I think I need to. Oh yeah. I need. Oh, but this is here. It's complaining that. Okay, so live debugging once again. Oh, right. I have to do a thing because now I'm trying to compile. Yeah, I know what I'm doing wrong. Okay, never mind. I need to do a thing that I had completely forgot about. So the problem, something that has slowed us down here that I didn't notice is that once we pulled the recompile process to happen locally, because I'm running tilt twice, it is happening twice. And I forgot about that. So now I remembered about it, so I'm going to fix it. So I have this environment variable called, oh, I don't, because I lost the thing that I was doing before. Okay. So build equals true if you're on the remote cluster, build equals false. Then here we're going to do Sorry, just doing some quick scripting here. So if, no, get out of here. Okay. If build compile equals, and now I'm going to do yeah. Gosh, I completely forgot about this. Okay. Right, so now we should be compiling just once with the previous. This should be the same as the previous workflow, but it should be a tiny bit faster because we're only doing things once. I hope. Let's see. Okay, benchmark. Recompiling. 1.5 seconds. And here, okay, this is outdated, so it's going to take more time. But it doesn't matter. Okay, so now I can finally do UPX. So UPX, I was calling this big. And then this was UPX glitch slash big Q1. And then move glitch slash big to glitch slash main. Okay. Okay, so is this done? I'm just going to wait for it to finish then. Okay, benchmark. Okay, 3.59 locally and 11 remotely. So as you can see now, it took a lot longer locally. It went from like 1.5, I think, was the fastest we got, to 3.5. That's because we're taking time to compress the binary. So if you're using a local cluster, it makes no sense to compress the binary. But here we went from 22, we removed debugging, we compressed the binary, now we're down to 11. So if you are using a remote cluster, then it makes a lot of sense to do this, because the time you spend compressing is less than the time you gain by sending up a smaller binary. And if you want to know how smaller the binary is, here's the output from UPX, the ultimate packer for executable. It went from 12 megabytes down to 5. So our first iteration here, it was 15 megabytes, and now it's 5. So that is pretty sweet. All right, Thomas.
Yeah, that's a pretty big difference.
Tell me, what's your take so far?
I mean, we're already into the realm. I've been doing a bunch of JavaScript lately, and my Webpack doesn't reload in 30 seconds. So getting it down to 3 seconds is fantastic. I think we're getting, you're going to surprise me, I'm sure, but I think we're getting about as fast as you can get at this point in time.
Yep, that's as fast as we can get. Yeah, this is the end state. You can see my notes here. We are down here right now. Let's see what Jerome says. The Knights of the House of Bash would like to know if it would be acceptable to use and instead of colon. I don't know. What do you think?
Yes, in preferable, in fact.
Yeah, why is that? Let's do that.
And is only going to run if the previous command has an exit code of 0, and semicolon is always going to run. And so you'll get some weird errors if you've got a command in there that doesn't work. But with and, it will fail, and you'll know immediately where it failed.
Right, so we should have it like this.
Yep.
Cool, and here should be and as well. Well, it's not going to fail.
I mean, it's echo. That one doesn't matter quite as much.
Unless you don't have a unless you don't have a standard out or something, but then you have bigger problems. All right. So this is basically the content I had prepared. I think we did pretty well. Something we didn't talk about was actually the very first step, where you should not be using CI when you're doing development. You absolutely should not.
Should not.
Do you have something you'd like to share on this topic? Because people, I tend to see a lot of resistance when I tell people, yeah, CI is good to ship to production. Don't use CI for development. That is sad and bad. And then people get very defensive. What do you usually tell people?
I write code that I don't want to see have anyone in the world see on a regular basis. In particular, I'm known for my poop and fart jokes in my code. And if I commit those and push them to CI, it always ends up in production. And so, like, if we ignore all of the other problems,
Uh-huh.
it's just to make sure that my temporary variables don't accidentally end up in production because I committed them and they didn't get removed during a review. But like, even if we ignore all of the benefits that you get from taking what did we go from 40 seconds down to 3 seconds, like if you just think about that, you can go and experiment 10x more. Like
Mm-hmm.
even if we put that aside, just not having to deal with the commit history
Mm-hmm.
and be able to have the like opportunity to go and experiment instead of worrying that every commit needs to be something that can get reviewed is very freeing. It gives
Yeah.
you a chance to go and figure out how to build it the right way instead of the way that Stack Overflow told you to.
Yeah. Fun fact, did you know that Mozart was a very big fan of poop jokes? Um, he would,
No,
yes, he would write poop poems to his family members in his correspondence. So you're in very good company there.
good, good. I figured that I just had stopped growing up at the age of 5.
Well, Mozart did too. So I mean, if he can do it, all right, so I have a little table here, and this is not the numbers from today. This is the numbers that I had compiled before. I'm having trouble hearing you. Who was that?
Thank you,
Alexa?
Siri. That
Siri?
was that was Siri. I had accidentally triggered my watch apparently.
Right. So these are numbers that I had run the last time I prepared this material. Um, And we basically have two winning workflows here. One is to sync the source code and recompile in container. The other is recompile locally and then sync the binary. And they work best in different situations. So, like Thomas said, um, if you're recompiling in container, you're going to need compile tooling there, and that's going to be annoying. At the same time, if you're running on a local cluster, you're not going to want your containers to be very powerful because you only have as much RAM as your laptop has, basically. And then recompiling locally as opposed to in the cluster is going to be better. So there are trade offs to each. Now, this applies to compiled languages. If you're using Python or JavaScript or anything like that, then it's a no-brainer. Then you just pick this one, and you just sync the source code, sync the source files, restart the process, and you're done.
I think it's valuable to point out because I think we can fit the CI discussion back in here.
Mhm.
None of these methods that we're talking about are actually meant to go and get a container image into production.
Yeah.
This is all for like developing while you're trying to figure out what to do before you post your code up for review. The
Mhm.
normal Docker process, what your CI does is what actually gets it into production.
Mhm.
And so don't think that you're like syncing files randomly into random pods in production with crazy permissions. That's not the way that you should be doing it. CI is the
Though,
right way to do that. This is a completely different phase of the development workflow.
though, now that you mentioned what people should not be doing, I'm sure someone's going to go out there and do it.
I mean, I've done it before. I mean, I've never done anything like that before in my entire career.
Yeah, me neither. Those newbies, right?
Oh.
All right, so I think that's what we had planned on discussing. Um, do you have some closing thoughts, some goodbye takeaways? And if you're in the comments and you want to say something, this is your last chance, so go for it.
Oh, my closing thought would be go and use Tilt. It's going to make your life a million times better. Spend the hours that it's going to take to figure out how to get your development process faster, because it's going to hurt for a couple hours, okay, a couple days, but it's going to make you infinitely more productive in the long run.
Yeah, when I'm presenting this material, I don't even say go and use Toad because then people think it's marketing and they stop listening. I just tell people like automate your development workflow as much as you can. If you use Tilt, it's gonna make me happy. Uh, if you don't use Tilt, like you don't have to use Tilt. There are plenty of other tools and workflows out there. Of course, Tilt's the best. I mean, right? But just automate your workflow and make developers happy in your team and make yourself happier by not having to struggle as part of your development workflow. Just make sure you can focus on what matters, and that's your code, and ignore Kubernetes, ignore Docker, ignore typing commands by hand. Just automate everything away, so that you can focus on what actually matters in your development process. We have a couple more comments, so let's address them and then wrap this up here. Is Webpack considered to be a compile stage for the purpose of that conversation? Would all that be super relevant for web folks? What do you think?
Web. So if you're doing this the slow way, you would go and do a Webpack build in the container and then go get to see it. Pretty much all of the web frameworks come with a Webpack dev server that will do hot reloads for you, which is pretty nice. That's my Webpack dev server reloads in 30 seconds for larger projects. But for development, I would actually use the ephemeral container stuff that we were talking about. So I'd have a Webpack dev run alongside the normal container and then have it reload. In fact, that's how I do development with Tilt. I've got a Go process that's an API server and a front end that's a dashboard, and I just run both through Tilt and have the syncing go and take care of that for me.
Mm-hmm. I would be interested to see that setup at some point if you're okay with sharing.
Yeah, you bet.
Cool. So Oleg says, "Great, thanks for your amazing presentation." I'm sure he's saying thanks to you because I screwed up the whole thing. Okay, spasibo, Oleg. And Jerome says, "Thumbs up." So thanks everyone for coming. Thank you so much, Thomas, for joining us. This was really cool. And I'm gonna steal all of your ideas for my upcoming GopherCon talk.
Please do. Please do. Tell everyone.
And yeah, thanks everyone for watching. Thanks everyone for coming. I hope to see you again next time. If please hit the, what do YouTubers say? Smash like and hit subscribe and click the bell thing. Most importantly, if you want to stay up to date on this content, go to dex.dev and subscribe to the newsletter. Because that's where we send like articles, guides, and all of that kind of stuff in addition to the live streams. So thanks everyone. Have a good evening or afternoon, or I don't know what time zone you're in. And see you next time. Bye.